Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Yeah, today we are looking at this question. It's under the topic force. So let us look at what the question says. It says, define the term vector quantity. So what is a vector quantity? A vector quantity is a physical quantity with both magnitude and direction. Okay, so that is that. Then comes the next question. It says, what is resultant vector? Okay, so what is it? Resultant vector is defined as the vector sum of two or more vectors. Or we can simply say it's a single vector which has the same effect as the two or more vectors added together. So let us look at that. So that is that. Then comes this question. It says, consider two forces below, F1, which is 43 newtons, and F2, which is 62 newtons, acting on point X as shown. So we are having this scenario. This is the point X, and you're having one force acting vertically upwards, which is 43 newtons, and another force acting horizontally, which is 62 newtons. Then comes the question. The question says, calculate the magnitude and direction of the resultant force on P. Okay, how do we get this this magnitude? Okay, here we notice that the two forces are acting at 90 degrees, and under this circumstance we are ought to use Pythagoras theory. Okay, if we go back to this arrangement where this one is pulling this side and that one is pulling this side, if we want to ascertain where the resultant force will be, it is very clear that it will be here. And if this resultant force, we call it F, so we can simply say F squared is equal to F1 squared plus F2 squared, on assumption that we can call this one F1 and we can call that one F2. So what is our F1? It is 43 squared. And what is our F2? It is 62 squared. From here, let's see what we get. So this is what we get after pressing the calculator. So what is our next step? Next step is to get the square root of both sides. So we find the square root of F squared, and we find the square root of 5,693. Okay, from there, you know that the square root of any square number is that number. So what do we have here is F. And let's see what we get. So that's what we get. Yeah, but the question says that we calculate the magnitude and direction. Okay, we are going to give our direction in terms of the bearing from the horizontal. So this one is going to be our direction, the theta. And how do we get it? Let's see. Yes, to get the angle, we we are going to use simple trigonometric ratios. And from what we have here, it is clear that tan theta is F1 over F2. And from there, we can get our theta. What is F1? Let us look at it. F1 is 43. And F2 is 62. So when we press the calculator, let us see what we get. So there we are. Our theta happens to be 34.75 degrees to the horizontal. So all in all, we can say that our resultant force is 75.45 newtons acting at 34.75 degrees to the horizontal. Okay. Then comes this question. It says, sketch head to tail vector diagram of the resultant force on P. Okay. How do we indicate this vector diagram? Okay, they want head to tail or tail to head. We can say this is our F1. Remember, a vector remains the same as long as it has the same magnitude and direction. So that is our F1. And we want tail to head or head to tail. So let us now represent this one. This one, its head is this one. So the head must come and meet this one. So let us have it. Okay. That is that. So that is our F2. So where is our resultant going to be? Now you have to know that resultant must be in this direction. If this one is coming like this one and this one is going up, resultant is supposed to be in the same direction. So let us have it. So in drawing our resultant, this is what we have to do. You show it there. And you must not forget that the direction is very important. The direction is that one. It's in the same direction as it is true. So what you have here is our head to tail vector diagram indicating the resultant. And this one is the resultant force or F net, as the case may be. With that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard. See you next time. Bye-bye.